Welcome back to another Devstream. I'm a bit tired today. I slept for like, I don't know, 11 hours or something like that. And my brain hasn't caught up to that yet. So I think it's gonna be a shorter stream today. I have no idea how long it will actually be, but we'll see how long my brain can cope with this nonsense. Because there's a lot of confusing stuff going on. I think we did... I think we did or the last Tuesday? Oh, hello Gojo. I have no idea if you're gonna think this is an interesting stream or not. It's not gonna be any more of the Hollow Knight today. I'm too tired. And I wanted to do some more work on my mini transformer. It's I'm trying my hardest to build an AI from the ground up by using ChatGPT as a teacher or guide or whatever. So it's mostly me sitting here and typing stuff and being confused about what I'm typing, so I don't know how interesting that will be to actually watch. So you might want to do something else. Watch some other YouTuber or streamer or something for tonight. Of course you're entirely free to stay here and watch me do this, but I'm not entirely sure how interesting it will be if you don't have like a interest in programming in general or AI or stuff like that. Why can't I use the scroll wheel? Okay, there we go. I do these kind of dev streams intermittently. I do some Python coding too, but my biggest program was about 120 lines. Well, I mean, it's not the size of the project that determines how impressive it is. As long as you write like very efficient code, then you can do a lot with 120 lines. I mean, it's a bit longer, but this is also mostly building blocks for something more complex, so I don't know. What was the program you did? Was it like some sort of calculator or, I don't know, some sort of data aggregator or, I don't know. The possibilities are literally endless, so for all I know you could have done anything. Let's see, I think we actually finished this, didn't we? Return IDX. Yeah. So, oh wait, we actually created these files before, I think. Tiny data, yeah. And it's empty. Nice. Move my keyboard a bit. So import data classes again, and torch as well. We create a data class called character tokenizer. Set the story, the dictionary of strings and integers, and lead us to a list of strings. I do remember we using story and ethos in the tokenizer, but I don't remember what for. It's just a hobby. I made a small text game about killing monsters. You could also find items or potions which can upgrade or downgrade your attacks. Oh, interesting. Interesting. I think I did something similar at one point when I just started out programming in C#, but that was a long time ago. I don't think I could have done that now. I'm not entirely sure I could do it in Python either. Well, probably. It depends on how complex you'd want it, I suppose. But how long have you been doing that hobby? Is it like something recent, or is it something you've been doing for a couple of years, or is it something you've given up on? Like, is it still something you do to this day, or is that project something you did a long time ago? Oh, okay. That's fairly recent. Do you have like something you want to do, like a goal of some sort? Maybe to create some more games, or I don't know, something entirely different? Turn self story. So what are we actually doing here? We're setting a dictionary and a list, and then defining the function vocab size, which returns the length of the vocab size. And what do these refer to? I don't know yet. For now, I'm just making something I think, if I think it would be an interesting idea. I also made a working shop. Oh, so you're like a customer and you have like a balanced amount of money, and then you can purchase items that gets like removed from the shop inventory and stuff like that. Did you like include shop restocking and stuff like that? Maybe like an inventory system? Story and Eidos are the two lookup tables your tokenizing uses. Story, dictionary, string to index. That was the acronym, or this acronym for this one, okay. String to index. Maps each token, a character or subword, to its integer ID. I guess that makes sense. And Eidos index to string. Oh, so we have T here, so string to index and index to string. That makes sense. I just forgot about it. A list of where position. I holds a token in text for ID I, same as dictionary ID to token, just stored as a list for speed. For now, infinite stock in the shop, but I will probably change that in the future. How does your program work now? Well, now it doesn't work at all. If you're referring to like my mini transformer. To explain simply what I'm doing, then I'm asking it for like. I began with asking it for a roadmap for giving me exercises from like basic Python all the way up to building my own large language model, or AI, whatever you want to call it. So now I'm on exercise 11 in the series, so to speak. And this is basically a mini character transformer. So sort of like a very tiny language model, you could say. Where it will be when I've written everything. I could simply copy and paste it to my IDE here, but I want to learn. I don't simply want to copy and paste whatever the AI spit out, so I'm taking the painstakingly slow road of actually writing it myself and trying my best to understand everything. And I understand about, I don't know, 70-80% or something about this code right here. It's gotten a bit crazy on the later lessons, like skipping steps and but it feels like it skipped steps on a lot of stuff. Like there's a lot of complex syntax going on that I'm not entirely sure on how it works exactly. But I'm having fun, and that's the important step, important part in the whole process, I'd say. We'll be able to speak like ChatGPT or something different. Well, the end goal is to have something like ChatGPT that will be able to speak back. But then you'd also need to have like a... or like the first goal is obviously to get it to talk back in text form. But I also want it to be able to do text-to-speech as well. So a bit like talk back in a voice. And that is my eventual goal. But this one won't be that advanced, I don't think. I'm a bit fussy on like the fine line between where a mini character transformer becomes a full transformer, like a full language model. I think this should still be able to spit back text at me, but I'm not entirely sure on like how comprehensive that text will be. But it contains like the whole learning sequence and everything. Like, let's see. This should be the minimal decoder only. I think this is the training as well. Yeah. So we have the code for training and everything, and now I think we're structuring some data. Looks like it. Oh, here we have the training, okay. But we're gonna call that from this one. So this is like the base, and then we have the data, and then we have the training that we're gonna call from the base. But there's a lot of math going on that I have no idea about. I tried so hard to learn the math behind it, but it wasn't fun. I don't enjoy doing like linear algebra and calculating differentials and all that stuff. It's not my jam, to be honest. And unless I'm forced to do it, I simply won't. But yeah. So we were here. So we have the encoding and wait, no, and decoding. List of integers. But if you're wondering, then I might play some more Hollow Knight tomorrow. I'm planning on it, but it's Father's Day tomorrow, and I'm gonna go to a restaurant in the evening with my parents. So I don't know how long I'll be out. So if I'm back like late, like really late, then there's obviously no point in going live and playing Hollow Knight. So fingers crossed, Hollow Knight tomorrow, otherwise it's gonna be either on Monday or Tuesday. Probably on Monday. We'll see. Yeah, it's Bongo Cat. I do like Bongo Cat. Do you use Bongo Cat as well? I saw like a list not long ago that Bongo Cat is like one of the most played games, so to speak, on Steam at the moment. I can see why. It's kind of neat to have a cat in the corner. Card tokenizer. So we want to return this data class. After we call the build character tokenizer function. Sorted for determinism. Determinism. Oh. Sorted for determinism. There we go. I hit the wrong keys. Vocab. I for I in enumerates vocab. Where did we go wrong? Oh, it's curly brackets, not square ones. And integers to index to. How can I already have forgotten it? Not syntax. Oh my god. String to index to string. I keep forgetting that for some reason. A fun issue I had with my shop was that it would take your money and say you bought an item, but it wouldn't appear. Scam! It's a scam! Someone built a scam center instead. Did you solve the issue? Was it like a typo somewhere, like or something, or just a very small issue? Okay. So another function called make splits and code listint. Oh, we simply forgot to add an item to inventory. So the shopkeeper simply took the money and then stared at the customer until they fucked off. Split ratio float default to 0.9. Why 0.9 though? That seems like an arbitrary number. You want to return a tuple of torch tensors. Tensor. What do we have? Oh, it's simply two tensors. Okay. Coded. How did you learn Python? Did you simply follow like tutorials on YouTube, or did you read the like some sort of documentation? Something like that? Code and split ratio. Train. Yeah, I also like dictionaries. They're very useful. Oh. Was that like a video course or an interactive course? I know there are like interactive courses where you like get asked questions and then you have to type in the answers yourself. I don't know how effective those are though compared to like traditional like documentation. It's only text. Okay. I feel like that's probably like one of the best ways to learn. At least for some people, I guess. It's not the same for everyone. Some people can't sit down and learn for the life of them, so then maybe interactive courses are better. But if you can stomach the like, not boring, but understimulating task of reading long blocks of text to learn, then I guess that's actually the most efficient. Or at least it feels like that to me. No, where did I go wrong here? Oh, got a closing. Oh, there we have that one. Okay. What app are you using for coding? Do you mean this one? In that case, it's Visual Studio Code. It's pretty lightweight, all things considered. I used in the past I used the very heavy ID, I forgot what it's called now, but the standard Microsoft stuff. PyCharm. I've never heard of PyCharm before. This is like a very universal text editor. You can program any language in it, practically. If it's C++, Python, C#, I don't know, HTML or JavaScript or whatever. You just have to install the correct extensions and then you can do whatever you want, basically. But if you're only doing Python, then I suppose it's overkill, in a sense. Does PyCharm like let you quickly set up project and like create virtual environments and stuff like that easily? Oh, forgot what the chest. Oh, a duplicate. Well, whatever. Return train valid. Torch tensor. A batch size of int. And a block size of int. We want them to be int, at least. And device as a torch.device. And we want to return another tuple. another tuple with two tensors. Tensor. Like so. I think yes, but since I only made small projects, I didn't really mess with the environment. Well, you don't really have to either. You only need to use as much as you need to use. There's no need to know everything. Deterministic. I feel like if you're trying to do like too much at the same time, especially when you're starting out in programming, it's very easy to get overwhelmed. It's much easier to simply narrow down the scope until you're like only doing the bare minimum and then expanding from there. At least that's my impression of it. Data is a Monday tensor of token IDs. This is the start index for the batch window. Turns X, Y. It shapes B and T. Okay. We set a data.dim or dimension. Put that to it. We're checking that it's 1. Then T equals block size. And B goes batch size. Not in caps, batch size. Make a window of length B times T plus 1. Compose wrap, not warp. Wrap if needed to keep it simple. So we're trying to get the batch. Tests. What are we testing though? Then we want to check if data.null. What is null? Is it null? It's probably null. There's no tool. No, here we go. See torch. Why can't I see it? Okay, whatever. It's probably very important, but I'm not gonna bother with it. Not for now, at least. So if the data.null is less than b times t plus 1, then we want to repeat to ensure enough context. Context. Set that repeat 2 equals 2b times t plus 1 plus data.null minus 1 divided by data.null, and we set data to data.repeat. So we're calling a function called repeat. Is this gonna say tensor again? No, it's actually giving us some explanation. Repeats this tensor along the specified dimensions. Unlike tensor.expand, this function copies the tensor's data. Warning! Tensor.repeat spelled differently from numpy.repeat, but it is more similar to numpy.tile. For the operators that are similar to numpy.repeat, see torch.repeat interleave. Okay. Then I want to set start to the position of the modular of data.normal minus b times t plus 1. And the data to start of start plus b times t plus 1. The length b times t plus 1. So much math. So much, I wouldn't say complicated math, but it's very much math, which makes it confusing in my eyes. And a bunch of complex syntaxes as well. Like, I'm not entirely sure why we put a colon here, for example. I think I've already checked that at one point, but I keep forgetting. Set the Y window to be the reverse of that. Of BT. Oh, T. And we return X to device. Y to device. See, this should be that script done. So to recap, we have a data class called character tokenizer with the property functions of vocab size, which returns. So if we call character tokenizer .vocab size, for example, we want to return the length of the index to string for the vocab size, and for the encoding we want to pass along a string and return the string to index of the characters for character in S. So we loop through all the characters in the string and we return its, well, we return the dictionary basically. Or do we return the dictionary? It says we're returning a list here. We're probably returning the list that we get from the dictionary. That would make sense. So we're assigning the characters to a dictionary and assign them a value. And then returning the list of those values. And then on the decoding side, we're passing along the IDs as a list of integers. Could be the same list that we actually got from the encoding. And we expect a string in return. So we return an empty string, simply to create an empty string, dot join. And then we loop through the index to strings and also we join the index to strings for I in IDs. I'm not entirely sure how it knows. Or wait, of course it knows, because the string to index or the story already has all the characters or all the, what were they called again? Not characters, but oh my god. like one of the most basic building blocks of AI. What do you call them, those blocks? I can't believe I'm forgetting it. A token, of course. Tokens. And so outside the data class we have the function build character tokenizer, and we can pass along the text as a string, and we want to return a character tokenizer. So vocab, we set that to sorted. So wait, so we set the oh, okay. So we're sorting the vocabulary, or are we sorting like the whole? No, this is probably only the vocabulary. So we're sorting that alphabetically, right? Probably. And then we're... what are we doing? Strings to indexes. We're setting to a dictionary, right? Yeah, a dictionary where the key becomes the character. And the value becomes its position. And then we set the index to string to simply be the vocabulary. Then we return a character tokenizer, or we're creating a character tokenizer from the class where we pass along story. We're setting its internal story to whatever we have here, as well as the eros to whatever we have here. And then we have the function make splits. So we have the encoded, which is a list of integers, and a split ratio. Split ratio. I don't know what a split ratio refers to in this case. I mean, the function is called make splits, but I don't know why it would default to 0.9. And we want to return a tuple of torch tensors. But we're setting n to the length of encoded, so the length of the list of integers that's being encoded. And we're setting the n train to be the max. Is it the max of one or this one? I forgot what max does. Doesn't it compare two values and sees which is bigger? Here we are. And with a single iterable argument returns its biggest item. The default keyword on the argument specifies an object to return if the provided iterable is empty. So we have arg1, arg2, etc, etc. Okay, so which one is larger, 1 or the integer of n times split ratio? Okay, I mean, the length of the encoded should be pretty long. So n times .9 should be the largest one, I suppose. But maybe you'd want to place a lower split ratio at some point, and then it would be good to have this check here. I don't know. But then we set the train to torch.tensor encoded, so you pass along the list of integers, and we have this here again. I feel like I need to know why that's placed there. Can we not? Let's do it like that. Why is there a colon there? Drink some more tea while it's thinking. Noise. You're looking at Python's slice syntax. In encoded and colon and train, a colon means take a slice. Format, sequence, start, stop, step. Start, omitted, start at 0, stop, omitted, go to the end. Step, omitted, 1. Have you messed with this before? I can't actually remember using this like intentionally at any point. So in your code, encoded and train from the beginning up to but not including entrain. Encode and then train colon from entrain to the end. That's how we split one list into train/valid parts. So if we have a list here with 6 items going from 0 to 5 and a entrain that's 4, then putting a colon before everything would be oh, of course. Then we'd only include the 4 in the list, or the 4 first one. And if we used start, then we'd only start after the 4 first ones. Slice or write exclusive, index stop isn't included. On Python lists, a slice creates a new list. On PyTorch tensors, a slice returns a view, no copy in most cases. Okay. So whatever entrain is, if it's 1 or something greater, we only want to include the encoded up to that number and no further. So it's 1, then it's only going to be one out of the list of integers that gets passed along in tensor. And set the dtype to torch.long. Is dtype data type? That is a data type, yeah, of return tensor. We want a long And a long, is that simply a double float? What is a long type of data? Maybe I should have written what is a data type of long, I don't know. In our context, long means 64-bit signed integer type. Oh, it's an integer, it wasn't float, okay. Int 64, 8 bytes per element. NumPy machine D type is NP int 64. There's only int arbitrary precision. The name long comes from all the Python low-level conventions. Byte matters for your code, so PyTorch API requires 64-bit integers, indices / labels. Neural net embedding lookups index tensors must be torch.long. Okay. And f.cross entropy targets must be torch.long with values in C0 to C-1. Your model weight / activation stay float as expected. Usually torch.float 32, only IDs / indices are long. Quick rule of thumb, logits activation losses. Float 32 or float 16 / b flow 16 later. Token IDs, class labels, gather indices. Long in parentheses int 64. How to set check D types? Well, this is a bit more than I need, but okay. Common mistakes to avoid: passing float targets into cross entropy results in type error. Casting model parameters / activations too long breaks training use floats. Targets outside or negative results in runtime error. Keep it simple: floats for math, longs for IDs. So it's a type of integer and a large type of integer. Or 64-bit integer. Let's see if we go back. So where were we? Here. And then we set valid to equals to torch tensor. Encoded and train. So this is the last in the encoded that we're going to include as a torch long. If n train is less than n, oh, we include this one if n train is less than n. That makes sense. So if it's less than the length of the encoded, then we'd want to set that to a tensor of torch dot of encoded n train. Otherwise, if it's past the bounds of n train, or past the bounds of n, I should say, then we'd want to set valid to torch.tensor with an empty value, basically. And then we return train and valid as a tuple. So train and valid. And then we have the function getBatch. It has the data, torch tensor, batch size, integer, block size, integer, position, integer, device, torch.device. And we want to return two tensors as a tuple. And it says deterministic slice-based batching for tests. Data is 1D tensor of token IDs. Pos is start index for the batch window. Returns XY with shapes BT. So assert that data.dim, like the dimension of the tensor, is equal to 1, so that it's one-dimensional. And set T to the block size, B to the batch size. Make a window of length B times T plus 1 from position. Wrap if needed to keep it simple. So we're checking if the data.null, and we don't really know what that means. Feels like... because I didn't ask that, did I? No, we asked about the colon. Let's see if we go up. What does this do? So data.null returns the total number of elements. Oh, num elements. Null is null in that case. Number of elements in the tensor data. For a 1D tensor, it's the same as length data. For multiple dimensional tensors, it's the product of all dimensions. Unlike len, which is just the size of the first dimension. It's O1, no scanning as reads the tensor shape. PyTorch also has torch.null data, which is equivalent. So if we have a tensor that's 10, 20, 30, and we call null on that, then we get 3 because it's 3-dimensional. And randn, is that a random number? I don't actually know what randn does, so this isn't helpful. Torch.empty. I don't know what that does either. But it would make sense if that's like 0-dimensional or 0 elements if it's empty. Torch.tensor 42, 1-dimensional. Makes sense because it's simply 1 element. In your get batch code, you use it to ensure the 1D stream has enough tokens for a batch window of B times T plus 1. Data.null equals length of the token stream. If it's too short, you repeat it enough times to cover a window of B times T plus 1. Then you compute a start index modulo, the valid range, and slice out exactly B times T plus 1 elements to make XY pairs. I ain't gonna lie. This is word salad to me, especially this sentence here. Then you compute a start index modulo the valid range and slice out exactly something elements to make something pairs. If you were using NumPy array, the equivalent is dot size. Well, whatever. So we're checking if the number of elements is less than this dimension. Right? And if it is, we repeat to ensure enough context, so we're doing what? We're multiplying the batch with the block size plus 1 plus the result of the data dot number of elements, -1. I don't know why we have +1 and -1 on the same line here. Shouldn't they cancel each other out? And then this is a division though. Oh, it's still division, it's ceiling division. Ceiling. But I thought it was floor division. Like you divided to the floor. Does it say ceiling division up here? It's further up, right? Yeah. See, does it say anything about... It does not say anything about ceiling division, so I'm gonna ignore that one. But it's division of a sort, either to ceiling or to floor. Then we set the data to equal to data.repeat. And what did this do again? Tensor repeat. Repeats this tensor along the specified dimensions. And this is the specified dimensions then. Then we set the start to equal the position modular data dot normal minus this, the batch and block size +1. And I'm not even gonna try to comprehend more of this, I don't think. Simply no point in it. But we got enough, I think. Enough of the information penetrated my thick skull. So let's move on to the next one. So we have train mini transformer .py, this one. So we do from future import annotations. Then we import arg parse and torch, and from tiny data, so import from the script we just wrote, build chart tokenizer and make splits and get batch. So we import those functions, and from mini transformer import mini transformer and model config. Oh, so we're actually doing most of the work in this script. I guess that makes sense. Then we have load text as a function. Path string or none. Want to return a string. So if path is none, tiny default corpus, small and quick. Want to return a hello world. Hello transformer. Hello love Hello, transformer. Tiny GPT says hi. We're Lorem dolor sittame. No idea what that means, but it's probably something very impressive. Then we'll open the path. Encoding UTF-8. All that jazz again. As F. Oh no, 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 no. Return f.read. So we're opening the file. Or we're reading the file with the UTF-8 encoding. And we're storing it as in the object we call f. Then we return f.read. So we return the text that we loaded from the path. That makes sense. Then we have the main function. LP arg parse. Argument parser. Description. Mini character transformer. CPU. Want to add in argument to that. Argument. Let's call that data. Give the description of path to a UTF-8 text file. And we default to none. And another argument. Steps. Type int. Default to 200. Add argument. Batch size. Also as an integer, and we default that to 16. Add another argument. Let's call that one block size. As an int, and we want the blocks to be defaulted to 64. Then we have the model. Same with the type as an integer, and this one we want to default to 64 as well. We'll default 64. Type like so. One more argument called layers. Type int. And we default that to 2. And heads. Type int. Default to 2. Oh. Argument. FF. Same as when I type int, and default to 256. Let's see, and another one. There's a lot of arguments. LR type. Ooh, sneaky. Type float. Default to 3 e minus 3. So a very small number. And another argument. Seed. Type int. Default that to 42 since that's the meaning of life. And then we add argument for gen. Type int. Default to 200. With the description of tokens to generate after training. Then args equals p dot parse args. So parsing all those args into the object args. Oh, forgot about that one. Have a little chest. I'm just gonna take a short 2-minute break. I'll be right back. And we're back. Just took a short bathroom break and I also gobbled up the last dammsugare. Or the... Would you call it the vacuum cleaner? Guess so. Sounds weird to very strange to say that I ate a vacuum cleaner, but it's a small confection. Not parmesan, but what do you call well, it's a chocolate dipped baked good, basically. Call it dammsugare. Very nice. So now we're back, and we can continue with the... we were here, right? Yeah. So after we set up all the arguments, what do we have to do next? The torch.manual speed manual seed to args.seed. Almost said speed again. I guess it makes sense. Manually setting the seed to whatever we define. Then we set text to load text. Args.data. So we're calling the load text function. And if there is no path, then we are gonna use this one here as the text, as the corpus. So the token to build character tokenizer, and we pass along the text. And encoding becomes toc.encode text. So the build character tokenizer.encode basically. Pass along the text through that. That becomes the encode object, and then we have train and valid as a tuple. So we do make splits, and we pass along encode and split ratio of 0.95. Okay, that's a different number to the default. Because if you remember, we set the default to 0.9. And then device. Torch.device. CPU in lowercase. CPU CFG becomes model config. With a vocab size. Talk.vocab size. We might wanna push this down as well. Let's see, like so. And then block size becomes args.block size. And layers becomes args.layers. And dot heads becomes args.heads. Dmodel becomes args.dmodel. And dff equals args.ff. And we set the dropout to 0.0, not O, 0.0, like so. So this is our configuration. Basically all the arguments we pass along. And this is something we set here as a dropout, which we don't have as an argument. Then we have model set to mini transformer, pass along the CFG, the .2 device. So we're doing a conversion as well. And the device is a torch.device CPU. This just sounds a torch transform, right? Here we go, and it doesn't say. Oh, it's simply a class. Pass along a neural network module. Okay. But we do convert it to a torch here in that case, right? Move and or cast the parameters and buffers. This can be called as function. Let's see. Does this mean that mini transformer gets converted into a torch.device CPU? Maybe a torch CPU device? And stored in model. Stored. We do really need to create another document after this one. Getting pretty deep into hallucination territory, I think. Short answer, it creates a mini transformer, then moves all its sensors to the given device CPU here. Oh, okay. Oh, two, so it moves them to. That makes sense. And since we set the device to a CPU device, then it moves them to the CPU, okay. And the Python object is referenced by the variable model. The device is a torch.device CPU, model is this one. What actually happens? Mini transformer with the config builds a Python neural network.module with parameters / buffers, weights, embeddings, layer norms, stats, your causal mask, buffer, etc. .2 device moves those tensors to the device you pass. With CPU, they live in CPU memory. With CUDA, they live on the GPU. It also returns the same module, mutated in place. Assigning it back to model is common but not strictly required. Model.2 device would also work. Notes: it does not convert the model into a device. Model stays a Python object, only its parameters and buffers change the device. And optionally D-type if you pass D-type. Your inputs must be the same device as the model. If your code get bash.2 device ensures x1. Okay. So then we can also switch to the GPU later if we want to. So let's go back. I'm getting sore in my throat, which isn't good, but I can hold on for a bit longer, I think. So where was we? We're here, model. Where were we? What was? Where were we? Opt torch.optim Adam W model parameters lr args.lr. Don't know what this is. Is it options? What is Adam W though? Simple training loop. So here we go with the training loop. The position to 0, model.train. Do we have a train function here? We do not. So it's something internal to the module, the neural network module, right? It should be. And then wait, we can follow this one, right? Yeah, it's something internal to the torch module. So for step in range, range from 1 to args.steps plus 1. So the default was 200 steps, I think. So for each step, set X and Y to get batch. And we pass along the data as train. And train is one of the valid, one of these split off here. What is this though? It has to be a list, right? But is it a list of strings? Why can't I get the tooltip to work? There we go. It's a tensor, really? And it's referencing back to itself. I thought this returned... Oh, yeah, of course it returns a couple of tensors. Okay. So... pass along this as a tensor. Let's see, and we pass along args.batch size. And args.block size. And a position and device. So we're getting a tuple in return, I think. A tuple of tensors. Yeah. Or not a tuple in this case. They return a tuple of tensors, but we split them up so X becomes a tensor in itself and Y becomes a tensor in itself. And then we increment position by X dot number of elements. See what it says. Move forward in the stream. Then we have underscore comma loss. So underscore become... Are those also tuples? Model XY. Wait, does this... How would that even work? Is it self-referencing? No, it can't be doing that. Let's simply continue on and ignore that one. Then do opt 0 grad. Set to none. True. Lost dot backward. Opt dot step. And then we check if step modulo max. Whichever is larger 1 or args dot steps. Divided to floor, I think, of 10. So if that is even, then we print an F string or formatted string where step becomes step 4D divided by args dot steps. And loss as curly brackets, can't forget that. The loss that I am dot 4f. Okay. Generate a sample. Gonna read this one more time to make sure everything is on the up and up. Step 40 or loss item, yeah. Looks correct. Then we have model.eval. Can't spell. Model.eval. Context of torch. Dot zeros. 1 1 with a data type of torch.long, and we set the device to device. Start with token ID 0. That's probably a good idea. And set the out to model.generate context max new tokens args.gen temperature 1.0 top k 50. To close this off as well. Oh, so here we're setting the temperature as well. Setting it to 1. Top K, is that the many classes we're gonna choose between? Maybe. Decoded. Token.decode, and we pass out 0 to list decode. Then we want to print new line sample. Print decoded. Then at the very bottom, if name equals name. So if we're not importing this, but actually running it, then we want to call the main function. So in essence, this should be everything. This script here is simply to test that all the math is working out as it should. And that's very important to do. So that's what we're gonna do as well. But that will have to wait until next time, I think. I feel my voice dying on me. And I don't want to lose it for tomorrow. We don't want to get sick. But we got a lot done. 2 whole scripts. The tiny data and the mini transformer. It's a bit... No, it's about the same as the last time. But still, 2 whole scripts. And then next time we can do the tests for this whole mini transformer. And also probably run it as well. So that should be interesting. See if it works. But yeah, that's all for today. Thank you so much for watching. And if you want to see more of this, then you know what to do. And I'll see you in the next one. Cheers!